Hi everyone. I hope everybody can hear me. Just let me know in the chat if you can hear me. You can hear me, right? Okay, we'll definitely start the class. So, my name is Mamta, and I'm a new joinee to Sankalp Learning. Who am I to you? I'm a nobody. So, we'll see how our relationship builds as we go on, right? So, today, our topic, I think, Sir has introduced two acids, bases, and salts. That's what we will be starting today. And let's get started. Okay. So if you have any questions, just let me know in the chat. Like if there is any clarification or if my voice is not audible, something like that, you just let me know. Okay. Yeah. So I'm presenting my screen so that we can get started. Let me know if you can see my screen as well. So everybody can see my screen. Yes, I hope you can see my screen. I'll get started anyways. So we'll start with an interesting observation, a small short clip that we will be watching. Because there's a YouTube video open here. Okay, anyways, so we'll just get started. Okay, good evening, everyone. So we know sodium chloride, we know it's a salt, but sodium as a metal, it is highly reactive. We cannot take sodium directly. It immediately reacts with air, producing flames. Correct? And then we have chlorine. Again, gas is very poisonous for us. We cannot inhale that. It will cause a lot of reactions as well. So now sodium and chlorine, when combined, they give you salt, which is very beneficial for us. Without that, we cannot survive. There should be sodium balance in our body, right? So nature has such tremendous examples like this where a single element is not at all safe, but then when combined, it becomes a very useful product. So nature has so many miracles like that. So we'll start the class with gratitude towards nature, and for us to be able to learn something about nature, and gratitude for your parents for providing us with this opportunity to be able to learn. Okay, so with that note, we'll get started with the topic. Okay, so now what is an acid? An acid is a substance that gives you hydrogen ions when you dissolve it in water. So you must dissolve it in water and then you get hydrogen ions. Now, hydrogen ion, as it is not very stable. It exists as a hydronium ion. So it combines with one molecule of water to give you H3O plus. So you can define an acid either ways. It is either H plus ion concentration or hydronium ion concentration, which is H3O plus. Okay, I hope that is clear. And some of the properties of acids, it tastes sour. I think you've already done the chapter of acids, bases, and salts in school. So you know some examples of acids. For example, citric acid, which is found in your lemon juice. You then have hydrochloric acid, which is in your stomach, which you cannot taste. But when you burp and when acid reflex happens, you can taste the sourness in your mouth. So when you're feeling like vomiting also, so that sourness comes, right? So these are some of the examples of acids we know that are sour. So an acid is sour and it turns a blue litmus paper red. Now a litmus paper is something that is used to check if something is an acid or a base. So it turns a blue litmus paper red. Now, how do we remember this? Because something turns blue litmus paper red and something else turns red litmus paper blue. So let's remember it like this. Acids, apples are red. So acid turns red. Acid turns red. It turns blue litmus red. Okay. Then let's remember bases. Bases turn red litmus blue. So let's say bananas are blue. I know bananas are not blue, but let's assume, let's make it blue. Let's just for the sake of fun, okay? So bananas are blue, bases turn blue. Bases turn red litmus paper blue. Now I think you'll never forget what turns what, acid turns what, correct? So I hope you get that. Then we'll be looking at the classification of acids depending on how they react with water. Okay. So there are weak acids and then there are strong acids. Now, what are weak acids? There's something that doesn't completely dissociate in water. Like all the acid molecules will not become H plus or H3O plus ions. Correct? So if that is the case, then it is a weak acid. Some of the examples of weak acids here, carbonic acid and sulfuric acid, H2CO3 and H2SO3. Okay. Now, a strong acid is something where most of the molecules, almost all of the molecules of H plus and Cl minus will dissociate into their respective ions and it will be a very strong acid. So examples here are HCl and H2SO4. Okay. Now what's a base? Acid gives you H plus ions. A base will give you OH minus ions. That is a hydroxide ion. So again, you can classify the base also similarly, where lesser number of OH minus ions, incomplete dissociation, that's a weak base. Complete dissociation, that's a strong base. Now, I think I already explained the red litmus, blue litmus. Now, the property is that it tastes bitter. So now, can you tell me if, I know you can't tell me, so if bitter gourd is actually a base? Not necessarily, okay? So anything that tastes bitter is not a base, but a base tastes bitter, okay? So and it also is very soapy to touch. So what are some of the bases you know? Soap, it definitely consists of a base. Baking soda that you use in cooking, if you make a paste of it, you feel it, it feels very soapy. So baking soda is a base. There are a lot of bases and acids that we use in our everyday life and that we come across in our everyday life. Right? So I explained weak bases and that. So some of the properties, usually acids are almost all of them colorless. HCl is colorless. So what are mineral acids and organic acids, right? Mineral acids are all the acids like HCl, sulfuric acid, which do not contain carbon compounds or hydrogen compounds. So HCl contains hydrogen compound, but it is still a mineral acid because it completely dissociates into H plus and Cl minus. Organic acids are like acetic acid, CH3, whatever acids are found organically, citric acid, that's an organic acid. Something that is found in organic compounds is an organic acid. So not all of them are colorless. Now bases are also colorless except hydroxides of iron and copper. These are the only two exceptions. And we talked about the sour and bitter nature of acids and bases. Bases are slippery and acids are completely soluble in water, but bases, only some of them are soluble in water. And the ones that are soluble in water are alkalis. Now, I'll just check YouTube if there is any, if you want me to go slow or do you want me to go slow or is the speed okay? Explain. Okay. You want me to go slow? That's what you mean by explain. Acids are sour in taste, base are bitter in taste. Correct. Salt properties. I'll tell about everything slowly, okay? I'm going to talk about it in detail as we go on. Okay, I think it is okay. I'll continue then. Yeah. Okay. So we will be looking at some of the chemical properties of acids and bases also. These are the 5 things we will be considering. reactions of acids and bases with metals. Now, what are metals? Sodium, magnesium, and more examples like that. Metal carbonates and bicarbonates. Sodium bicarbonate, sodium carbonate. These are metal carbonates and bicarbonates. Metal oxide. What is a metal oxide? Calcium oxide. Calcium is a metal. Calcium oxide is a metal oxide. Non-metal oxides with bases. So carbon dioxide, that's a non-metal oxide. Okay? And reaction of acids with bases. What will happen when we combine acids and bases? So these are the 5 things that we will be talking about. Okay. Now, what will happen when you react acid and a metal? So what will happen is always acid and a metal will combine to form a salt and hydrogen gas. Okay. So even a base, when you react it with a metal, it will form a salt and hydrogen gas. So this is always the case. Metal and acid will form salt and hydrogen gas. Base and metal will also form salt and hydrogen gas. Now, do all metals form salt and hydrogen gas when you react it with acid? Take a minute and think about if there is any acid that doesn't react, if there is any metal that doesn't react with acid. Maybe gold. Gold is a very stable metal. That is why we wear it as well. Correct, no? It doesn't usually react with most dilute acids and bases. So if is this okay? Just let me know. This is okay? Yeah. Bases are bitter. This is correct. Now, reaction of metal carbonates, for example, sodium carbonate with hydrochloric acid, what will happen? It will give you salt, NaCl, our table salt, carbon dioxide, and water. So now, S here represents a solid, HCl is an aqueous solution, if there's any confusion with that, and L here is a liquid. Okay. So, one interesting observation is that bases do not react with metal carbonate. So you take sodium carbonate or sodium bicarbonate and add a base to that, there will be no reaction. So bases do not react with bicarbonates. So we'll be looking at a short video that will explain some of the things that we just discussed, like how zinc metal when added to hydrochloric acid, the reaction, how the H2 gas appears. So that's what we'll do. Can you hear the video? Just let me know if you can hear the video. Can you hear the video? Yes, okay.
Solutions, HCl solutions. We require 2 test tubes placed in a test tube rack, red and blue litmus solutions, HCl solution and a dropper. Take the red litmus solution. Pour the red litmus solution into a test tube. Take the blue litmus solution. Pour the blue litmus solution into another test tube. Take a few drops of HCl solution from its bottle using a dropper. Add this to the test tube containing the red litmus solution. The color of the solution remains the same. Again, take a few drops of HCl solution from its bottle using the dropper. Add this to the test tube containing the blue litmus solution and note the change in the color. The color of the solution changes from blue to red. HCl is an acid with the pH value below 7.
So now an acid will turn a blue litmus solution red. So acids turn red. A similar experiment is also present where bases turn red solution blue. Okay, so we'll skip that part and we will go to the part where reaction of zinc and HCl happens. So let's look at it.
We require a test tube, a small piece of zinc metal in a dish, a spatula, HCl solution, a dropper, a stand with a clamp, a single board cork, a jet tube, Bunsen burner and a matchbox. Using the spatula, transfer some of the zinc metal from the dish into the test tube. Take a few drops of the HCl solution from its bottle using the dropper. Add this to the test tube containing the zinc metal. Clamp the test tube to the stand, then close the mouth of the test tube with the cork and pass the jet tube through the hole in the cork into the test tube. Now, bring the clamped test tube downwards to heat it over the Bunsen burner. Hydrogen gas is evolved on heating. Take the matchbox and light a matchstick. Bring the burning match near the mouth of the jet tube. Hydrogen gas coming out of the test tube causes the flame to flare up. Then, with a mild explosion and producing a popping sound, the flame dips out.
Okay, so a similar thing happens with a reaction with a base also. Sodium hydroxide also, a hydrogen gas burns with a pop sound. Hydrogen gas comes out of the reaction in this case as well. So, okay, so we'll look at another reaction where metallic oxides react with acids. So now calcium oxide, which is a metallic oxide, is reacting here with hydrochloric acid to give you calcium chloride and water. Okay, now metallic oxides like calcium oxide, it is said to be basic in nature. Now why is that? I said a base is something that gives you hydroxyl ions, OH minus ions, correct? Hydroxide ions. So here there is no hydroxide ion, it's CaO, calcium oxide. So why do you think it is basic? Okay, so it is basic because it will react like a base. Because metal oxide plus acid will give you salt and water. Now, acids, when they react with bases, they also give you salt and water. Metal oxide in this case, it is reacting with acid to give you salt and water. So that is why we say it is basic in nature. Okay. So it is not a base, but it is basic in nature, not a base. Okay. Then non-metal oxides with bases, carbon dioxide here, which is a non-metallic acid, we are reacting it with sodium hydroxide, which is a strong base. We will get sodium carbonate and water. Okay. In this case, non-metal oxide is reacting with base. It is behaving like an acid because it is giving you salt and water. So we say it is acidic in nature. So something that reacts with a base and gives you salt and water is said to be acidic in nature. Okay. I hope that is clear. Is that okay? I'll just look at the chat. Is that okay? I'm getting any responses. Yes. So it's okay. That's good. Okay. Now we just talked about how acids and bases react together to give you salt and water, right? So that's what happens with all the acids and bases. We are treating sodium hydroxide with hydrochloric acid. We are getting salt, table salt, sodium chloride and water. So that's a neutralization reaction. Now let's think of some neutralization reactions in nature. So you have heard about mixing baking soda and lemon juice. Now what will happen when you mix lemon juice and baking soda? Lemon juice is acid, baking soda is a base. Both will neutralize each other. Now how can you use that to clean DIYs? Can't use, no, because it is neutralized. Effect of acid also is gone. Effect of base is also gone. Correct. So if you want to effectively use the remedy, what you should do, you should first clean it with lemon juice and then clean it with sodium hydroxide or a base, baking soda. Okay. Or clean it with base and then an acid. So then you get uses of both the things. Correct. No. So another neutralization reaction, you can see we take an antacid when more gas happens. Correct. No. If you feel acidity, you take an antacid, which is magnesium hydroxide. So that is again a neutralization reaction. You're neutralizing the acid in your stomach. Correct. There are multiple examples of neutralization reactions which we will be looking at further as well. Okay. Now this is the summary of the reactions. You can take a screenshot of this just to remember, like a mind map of what are all the reactions we studied. If you can take a screenshot quickly. If it's done, I'll proceed. Okay. Yeah. Now what are alkalis? We already talked about that, right? An alkali is a base which dissolves in water. I told you not all bases dissolve in water. If it dissolves in water, then it is called an alkali. So some of the examples here, sodium hydroxide and potassium hydroxide. And alkali will always have a pH more than 7. We'll be talking about pH shortly. And all bases have pH more than 7. All acids have pH less than 7. Okay, we'll talk about what is pH and all of that shortly. Okay. So now some of the properties of alkalis, they're very soft and they have low density. So you have to store them in mineral oils. Now, mineral oil is a petroleum product. So what will happen if you store them outside? They react very easily. They undergo corrosion. So you have to store them under mineral oils. And they have very low melting point and boiling point also. And they have a characteristic color to the flame. So now what do I mean by characteristic color to the flame? They burn with different colors of flame. For example, you can see sodium chloride is burning with one color, barium chloride a different color, lithium chloride a different color. So this is what I mean by a characteristic flame. Okay. And alkalis react easily with halogens. Now what are halogens? Chlorine, bromine, iodine. These are all halogens. So you can easily treat alkalis with halogens and the reaction is very fast. Okay. And they must be stored in mineral oil solutions. So is there any question with this part? If there's a question, just let me know. Oh, you want me to go slowly? Okay, I will go slowly. Yeah. I'll talk about combining strong acids and strong bases. Okay. Okay, now let's talk about dilution of acid. Now, what is dilution of acid? More water you add to an acid, it becomes diluted. So they say, right, when you eat food, don't drink water just before having food. They say that it will dilute the acid in your stomach and the digestion will not be proper. So it is a process of dissolving an acid or a base in water. And the reaction is highly exothermic. Now, what do I mean by exothermic? It produces a lot of heat. So we should take care when we mix acids and water together. So how should we mix it? We should always take water and add acid to it. Okay. What will happen otherwise? If you take acid and add water to it, the reaction will cause a disaster. You don't want that to happen. It's like adding oil, adding water to oil, boiling oil. You know the reaction, right? So you always add oil to water. There will not be much reaction. But you add water to oil, then it's a disaster. Correct? So I hope that is also clear. So we'll be looking at a small simulation for whatever I just explained. Here. Okay, so now we have water here. Let's connect this pH scale. A pH scale is something that will tell me if a solution is an acid or a base. So the range of pH, let me first talk about the pH ranges, then I can show you this one easily. So a pH range goes from 0 to 14, where 7 is neutral. A distilled water solution will have a pH of 7. It's neutral. Anything that's less than 7, it's acidic. Anything that is more than 7, that is basic. Okay. Now, pH is a universal indicator of if to show if something is acidic or basic. We use it in multiple instances to check if something is acidic or basic. For example, soil. Soil should be almost slightly acidic and towards neutral. Only then the plants will grow. If it becomes more basic, then the plants will not grow. We do different remedies to change the soil consistency as well. So now let's look at battery acid. We'll connect the pH meter here. It will measure the pH. So right now the pH is 1 and we'll start adding water here. The pH keeps increasing. That means it is becoming more and more basic when I add water. So it is getting diluted. So if you dilute an acid, the pH increases, becomes more basic. Okay. Now let's take something that is basic. Let's take hand soap here. The pH is 10. You start adding water. The pH decreases. That means it becomes more and more acidic. So dilution increases or decreases the basicity and acidity of different things. Okay, that's what dilution will do. That is clear? Is that clear? Oh, let's see. Battery acid is an acid that's present inside your batteries. Universal indicator, I'll come to that. I have not come to that slide yet. Okay. I had to show another. Yeah. So this is another simulation that I wanted to show. So strong acids and weak bases, somebody was asking, right? Let me have a base here. So this is a base. I'll have a strong base. Hydrogen OH minus ion concentration will increase if the acid becomes stronger. In weaker bases, the OH minus ion concentration will be lesser. So that's how you can know if it's a strong base or a weak base. Same thing happens with acid also. Hydronium ion concentration decreases with weaker bases, increases with higher bases. You can also see the pH, how the pH changes. If the acid is weaker, the pH is higher. If the acid is stronger, pH is lower. Lower the pH, stronger the acid. Okay. You can also test it with a pH strip. So this is an acid, right? You can compare the pH value with a pH strip as well. And one more interesting thing is all acids and bases, they dissociate in water to give you electrons and positrons. So you have positive ions and negative ions. So if you connect a battery, you will get the light, you will get the electricity because it is very conductive. That's how we know acids, when dissolved in water, and alkalis, when dissolved in water, they are good conductors of electricity. Okay. So this is an illustration that's present in your NCERT book, which says that higher the as the hydrogen ion concentration decreases, the basic nature increases. As it increases, the acidic nature increases. Same thing happens with your OH minus ion concentration as well. So here OH minus is more, so the basic nature is highest here. Okay. Now we'll talk about indicators. What's an indicator? It is something that will show some representation. For example, you have a car indicator. What does it show? It will show the other person if you are going to turn right or left. Now, what is an indicator here? It will show if something is an acid or a base. We took the example of pH. So pH is one of the indicators. But pH is a universal indicator. I'll come to that. But we have other indicators. Litmus paper, which is made up of lichens. Now, what is a lichen? It is something that grows in a very clean environment. So if lichens are seen on the trees, it shows like white patches. If they're seen in trees, then it is said that the environment is very clean. So consider yourself lucky if you're in a place like that. You're living in a clean environment. Right? So litmus paper is made out of that, lichens. Now, we know how litmus paper changes color. We just discussed that. We have turmeric. Now, you know, if you have a turmeric stain on your shirt, if you wash it with a soap, then it becomes red color. Correct? No. Now, that's again, turmeric is an indicator. Okay. So that's a natural indicator, litmus and turmeric. We have synthetic indicators like methyl orange and phenolphthalein. We'll see the colors that they produce. I have given you a table here of different indicators that change to different colors depending on base or an acid. So I want you to take a screenshot of this as well so that it's easy for your reference. So screenshot is taken. Okay. So we talked about natural indicators, synthetic indicators, methyl orange and phenolphthalein. Phenolphthalein will give you a blue color when you mix it with an acid. Okay. So olfactory indicators, they give you smell indication. So onion is something. So onion will lose its smell in a base. In an acid, the smell will remain. So there are some indicators that show with smell also. So that also is given in the table here. Okay. So now, how do you prepare a universal indicator? Because we saw different indicators like turmeric, litmus, and there are other methyl or orange, phenolphthalein. Now, universal indicator, you mix a lot of indicators together, solutions that can give you different colors, and you dip the pH paper in that universal solution of different indicators so that it can change colors respectively. Okay. So now that becomes a universal indicator. It can give you a range of colors which will show different values of pH, which will tell me if something is acidic or basic. Okay. So P stands for potence, which means power. P in pH stands for power. 0 is very acidic. 14 is very alkaline. The pH of a neutral solution is 7. We discussed most of this already. So yeah. And some of the examples of every pH is there in this table. If you want to take a screenshot of this also, you can take. So water, neutral, 7. All the acids come on the left side, 0 to 6. Milk is also slightly acidic. So coffee is also slightly acidic. So wine, vinegar, lemon juice. Hydrochloric acid is the strongest here. And then you have all the cleaning agents, soap, bleach, the drain cleaner. So all the bases are mostly used for cleaning, correct? So these are all very basic. Okay. Now, where do we use pH in everyday life, right? So in nature, in atmosphere, there are so many gases that react with water to give you acids. For example, nitrogen dioxide will give you nitric acid. Sulfur dioxide will give you sulfuric acid. Now, these are all present, and when it rains, it all goes into our oceans, rivers, seas, and all of that. So this becomes acid rain, and it is very dangerous for monuments, um, structures, man-made structures. It is also dangerous for the aquatic life, the fishes and all the animals living underwater as well. So in order to neutralize this, some bases are added to water. For example, bleach is added, correct? No? So that's something that pH for plants and animals works. And soil pH, again, I was talking about when soil is too acidic, we cannot grow anything. If it's too alkaline, we cannot grow anything. So it should be either neutral or slightly acidic. So when will it be slightly acidic? If you add organic compost, something that you make at home, plant compost, organic manure, that is slightly acidic. Why? Because any bacterial growth will increase the acidity because they produce acids when they decompose material. Okay, so that is why compost is slightly on the acidic side. And how do we neutralize it? Or how do we increase the acidity or increase the basicity? By adding specific amount of bases and acids to bring the pH of the soil to a particular range. In our digestive system also, we know we have HCl in our digestive system. We take antacids, which is most of the times magnesium hydroxide, which is also called milk of magnesia. So this will neutralize the acid. It is used in medicine as well. And does our teeth decay because of pH change? It seems yes. So when we eat food, there is bacteria in our mouth that is breaking down the food in our teeth. So when it breaks down the food, it is generating acids. Now acid, it can erode the teeth enamel. So that's how the tooth decay happens. Now how do we neutralize it? We brush our teeth. What does it contain? It contains bases, cleaning agents that neutralizes the acid in our mouth. So that's why we say we have to brush our teeth in the night. Otherwise, the entire night, bacteria is eating our teeth. Not exactly bacteria, acids created by bacteria. Now you know, correct? Okay. Now, there is a chemical warfare that's happening between animals and plants all the time. You must have gone near some plants and immediately get pricked or hit. And even honeybees, when they bite you, ants, when they bite you, there is a acid they inject, which is formic acid. It's also called methanoic acid. Now, how do you neutralize that? You can take a baking soda solution, make a paste, and apply. You will immediately feel relief. And there is this plant called nettle. It again. If you go near the plant, it touch it. There is a formic acid being injected into you. Okay, how do you neutralize that? There's this plant called, this is your nettle plant and this is your dock plant. So these two plants always grow together. Now, nature is so amazing, right? It is growing both an acidic plant and a basic plant together. So if you get stung by nettle, you take a dock and you apply. So you neutralize the reaction. Okay, so many examples like this exist. Quite interesting. And we were talking about some naturally occurring acids, right? So vinegar is acetic acid. It's a weak acid. Orange, citric acid. Tamarind, tartaric acid. Tomato, oxalic acid. So these are all natural acids, organic acids. They're not HCl or sulfuric acid, which are inorganic acids. Okay. Lemon, citric acid. Ant sting, nettle sting, bee sting. This is all methanoic acid or formic acid. So now you know if you get stung, how to neutralize the sting. Okay. Now let's talk about salt. So when I say salt, what do you think of? You just think of table salt. But a salt is not necessarily table salt all the time. There can be multiple different kinds of salts depending on the type of acid and the type of base that you're combining together. Okay. So what is a salt? It is a resultant of acid-base reaction. Okay. Now salt can also be acidic and basic. When will a salt be acidic? When will a salt be basic? We'll look at that. So, okay, let's look at this first. If you mix a strong acid and a strong base, then you'll always get a neutral salt because the reaction is complete in equal amounts. What I mean. But if you mix a strong acid and a weak base, because the acid is very strong, there's not enough base to react with the acid, it will become an acidic salt. Okay. Weak acid and a strong base, it will give you a basic salt. So more acid, it will become acidic salt. That is strong acid, acidic salt, strong base, basic salt, weak acid, weak base, it will be a neutral salt again. Okay. So you can take a screenshot of this as well if you're asked for a reaction of neutral salt, acidic salt, basic salt. So I hope you have taken the screenshot. Lichen is an indicator here. Okay, so some of the properties of salts, we saw that they can be acidic, basic, or neutral. They conduct electricity. I showed you the bulb experiment where acid and a base both conduct electricity, and a salt conducts electricity when dissolved in water. And they're hard crystalline solids. You must have seen how a salt appears, right? Unless it is powdered and anti-caking agents are added to the salt will remain a crystal. They have high melting point. They melt at very high points. So you know how they use salt for frying papads and all, no? It will not easily melt. Salt will not melt when you heat it. So salts are insoluble in organic solvents like kerosene and petrol. So you can't mix salts with kerosene or petrol. It only dissolves in water. Some of the salts, depending on the base and the acid. Sodium hydroxide and hydrochloric acid will give you sodium chloride, which is table salt. Other salts that you get are potassium chloride, sodium sulfate, depending on which base and which acid you're reacting with. So you can also take a screenshot of this if you like. Now let's talk about common salt, table salt, sodium chloride. Formula, you know it is NaCl. You treat hydrochloric acid and sodium hydroxide, you get sodium chloride. Now again, this is a wonder, right? Because HCl, it is very strong. It will burn you. It is not burning the stomach because there are some protective layers within the stomach. But otherwise, it will burn you. And sodium hydroxide also is very corrosive. It will burn your skin. It will give a lot of reaction. But together, if you mix it, you will get sodium chloride, which is beneficial for us. So again, a wonder, right? So you use it in food, obviously. And you also use it as a raw material for manufacturing other chemicals like sodium carbonate, sodium hydrogen carbonate, and all of that, like baking soda, washing soda, all of these salts. Okay. Now, sodium hydroxide, NaOH, it is also called a caustic soda because it is very corrosive. You shouldn't touch caustic soda with your bare hands. It is quite dangerous. So that's why it is called caustic soda, corrosive soda. Okay. So when electricity is passed through an aqueous solution of sodium chloride, so when you pass electricity through sodium chloride solution, you get sodium hydroxide and chlorine gas. So this is called chlor-alkali process, where you pass electricity through sodium chloride solution, that is salt solution, and it decomposes into sodium hydroxide, chlorine gas, and hydrogen gas. It's called a chlor-alkali process. There's a nice illustration also given in your NCERT book where they talk about where chlorine gas is used, where hydrogen gas is used, and all of that. Okay. So where do you use sodium hydroxide? It is used in making soaps, the body soap, detergent, paper, and fibers. It is also used for degreasing metals because it removes the dirt. Now, I told you that sodium hydroxide is very dangerous and all that, but you can ask me a question, right? Like, how is it used in soap? We are using soap on our body, correct? No, why it is not damaging our body? So why is that? There is a reaction happening there also. So sodium hydroxide reacts with something else in a reaction called saponification, where it is no longer sodium hydroxide, it is something else. So it is not affecting our body. Okay, but if the soap is polyformed, if it is not well pH balanced or something like that, then the soap will definitely affect our body. That's why we have to be careful when we use soap also, you see. So bleaching powder, where do we use that? The chemical formula is CaOCl2, calcium oxychloride. That's your bleaching powder, which is used for cleaning your toilets. It's added to water to make it germ free. Correct. So how is bleaching powder formed? You react calcium hydroxide with chlorine gas, and you get bleaching powder in water. So it is used to make drinking water germ free. It is also used as an oxidizing agent in many industries. Okay. Baking soda, which is what you use in your cooking. Chemical formula is sodium hydrogen carbonate. When you treat NaCl, that is salt, with water, ammonia, and carbon dioxide, you get NaHCO3, which is sodium bicarbonate. Sodium bicarbonate or sodium hydrogen carbonate is your baking soda. You also get ammonium chloride along the sodium bicarbonate solution. Okay. So where do we use baking soda? We make pakoras. We make it crispy. How does it become crispy? Let me show you this reaction. So when you heat sodium bicarbonate, you get sodium carbonate, which is which will increase the space within the food, sodium carbonate, because carbon dioxide is being released. Okay, so what does carbon dioxide do? You know how your carbonated drinks also work, right? It fizzes up. So that's what a cake or anything that you're cooking while baking, it's increasing the space within the food by releasing carbon dioxide within it. That's what happens when you heat your sodium bicarbonate. Okay. So it is also used in soda acid fire extinguishers. Some fire extinguishers also use sodium bicarbonate because carbon dioxide, when it is released in the reaction, it will decrease the concentration of oxygen. Now, what happens when you decrease the concentration of oxygen? Because burning requires oxygen, it will stop burning. So that's how it is also used in fire extinguishers. Okay. Then washing soda. Washing soda is used for washing things like cloths and other washing purposes. Chemical formula here is Na2CO3. Okay, 2 molecules of sodium and CO3. Now, it is written with 10H2O. Now, what is this 10H2O? We'll see what that is shortly. Okay, it's called water of hydration. We'll see what is water of hydration shortly. We will use washing soda for removing permanent hardness of water. That is again cleaning agent for domestic purposes. So what is water of crystallization? It is the amount of water that is necessary to maintain the crystalline properties of certain metallic compounds. Now, when we write NaCl, sodium chloride, we don't write it with some 10 molecules of H2O, 20 molecules of H2O. We don't do that. It can be crystal without the water. But there are some salts that cannot be crystals without that water molecule. So it is that minimum amount of water that is necessary to keep the crystal, to maintain the crystalline property. Okay. So gypsum here, it is in 2H2O form. It is a crystal like this. 2 molecules of water. Calcium sulfate with 2 molecules of water is gypsum. Now it is like this. When I heat gypsum, I'll get something called plaster of Paris, which is used in construction. That white powder that you use to mix and it will become solid after you mix it with cement, right? So that's your gypsum. Okay. And copper sulfate, again, when you heat it, when you take it, this is an experiment that is there in your book also. If you take copper sulfate and heat it, put it in a test tube and heat it, it will become a white powder. It will not look like a crystal. And you add water to that again, it will start becoming blue again. So that is why we have a water of hydration for some salts. Okay. Even washing soda has 10 molecules of H2O, water of hydration. Okay. Is that clear? Is that okay? Okay. Is it okay? Okay. Okay. Yeah. So I was talking about plaster of Paris, right? Now, why is it called plaster of Paris? That's your homework. You find out why it is called plaster of Paris. Uh, Chemical formula is CaSO4, calcium sulfate, with half a molecule of water. So how do you get that? When you heat gypsum, which was in the previous mesh, this is gypsum. When you heat that, you get half a molecule of water and 3.5 molecules of water separately. Now, what do I mean by half a molecule of water? It can't be half hydrogen and half oxygen, no? One H and half O. No, it can't be like that, right? So what is that half a molecule of water? It is half because one entire CaSO4, calcium sulfate, is shared by uh, 2 molecules of CaSO4 shared by one water molecule. That is why it is half a H2O. If you write the bond and all that, you can see that. But right now, you understand that 2 molecules of calcium sulfate share 1 molecule of water. So this is something that you use when you fracture your bones. It is used in the medicine. It is used to make toys, okay, make the surfaces smooth, construction, and other places. So this is your homework. And I'll give you this mind map so you can, in one glance, you can revise the entire acids, bases, and salts. So, yes. Tomorrow in the next class, we can solve some questions. You let me know what kind of questions you want me to solve. If you want me to solve textbook questions or other kinds of MCQs or something like that. That is the case, you just let me know in the chat. And if you have any questions or any topic that you want me to re-explain, you can just tell me in the chat, okay? And yeah. Oh, so many messages. Everybody understood how was the session? Okay, something unrelated also is unrelated chat also is happening. Explain what? You're just saying explain. Okay, you want me to explain why plaster of Paris is called plaster of Paris? Okay, it is because gypsum was found in one of the hills in Paris, which is in France, right? So they were heating gypsum there and they were producing plaster of Paris. So that's why it's called plaster of Paris, because of the mine in Paris. Yes, it is used to make building surfaces smooth. Fracture of bones, correct. So how was the session today? What was your experience? Like, because this is my first time, I want you to give me feedback. Like, is there something that I can improve? What can be done better? So, okay, you want me to explain pH in our digestive system. In our digestive system, which is in the stomach, the pH is very acidic. So pH will be very low because it contains hydrochloric acid. Right. Okay, tomorrow's class I will teach slow. Thank you for the feedback. Full form gypsum. Okay, okay. Did you enjoy the class? Did you learn something? Was it useful? Crystallization. Okay. Now let's go to crystallization. So you look at gypsum here, it is in the form of a crystal. But when you look at gypsum that is heated, it is in the form of a powder. It is no longer a crystal. So crystal is like a diamond, right? Anything that is in the shape of hard edged crystal, like salt is a crystal, right? How you know the crystal salt, correct? So that's how almost all the salts are. They're crystalline form. So when you heat this gypsum crystal, it will become this powder called plaster of Paris. So water of crystallization is the minimum amount of water necessary for that salt to be in crystal form. Otherwise, it will become powder form. Okay. So what should we do tomorrow? Shall we discuss textbook questions? Examination questions will mostly be textbook questions, or you want other kind of antacid is formic acid. Difference between crystal and a dilution. No, I didn't get your question. Difference between. Okay. How is plaster of Paris, ma'am, using fractured how this powder? So when you add water back to plaster of Paris, no, it hardens. It becomes a solid. So that's how it is used in medicine. Okay. Explain in Kannada. I was told that this is an English medium class and I'm supposed to explain in English. But if you want me to add Kannada as well, if most of you want me to explain Kannada also, then I can talk a little bit in Kannada also. Okay. 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 You want me to discuss application level questions? I'll get some of those questions tomorrow. So textbook questions, I think you all have answers for. Applied questions, applied questions. Okay, I'll get some applied questions for tomorrow's class. Okay. Hmm. How is gypsum formed? When you add water to plaster of Paris, it becomes gypsum again because it crystallizes. Right. Okay, so I guess I'll end the chat then. Bye everyone. Take care. Thank you for attending the class today.